5-3, bisectors in triangles. All right, so here's a vocabulary for this lesson. We have concurrent, which is when three or more lines intersect at one point. Those lines are said to be concurrent. Point of concurrency, the point at which they intersect. So when you have three more lines that intersect, that point where they intersect is called the point of concurrency. Then we have what's called the circumcenter, which is the point of concurrency of the perpendicular bisectors of a triangle, which we're going to go over, and the incenter of a triangle, which is the point of concurrency of the angle bisectors of a triangle, which again, we're going to go over. So make sure you write these down. There's going to be two more vocab words that I'm going to have you write down in your notes as they pop up. Okay, but it'll be easier to show you those graphically than try to explain those in words here. So make sure you write these down. All right, theorem 5-6. Okay, this is the concurrency of the perpendicular bisectors theorem. All right, it says the perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. So if you look, these red lines here, xp, py, and yz, are the perpendicular bisectors of triangle ABC, meaning they bisect, px bisects this side, AB, and is perpendicular. Py bisects side AC and is perpendicular. And PZ bisects BC and is perpendicular. Now what it means when it says equidistance from the vertices is these blue dotted lines here that come from the vertice to the point of concurrency, which is the circumcenter. Okay? All three of these blue lines, as you can see, are the same length. So when you draw in the circumcenter of the triangle, it is going to be equidistance from all three vertices of the triangle. All right, and then of course P is the point of concurrency, and it is the circumcenter. Okay, it is the circumcenter of the triangle. All right. Now, so the point of concurrency of the perpendicular bisectors is the circumcenter. So that's this point P right here. Now, the next vocab word I need you to write down is circumscribed about. Okay, this circle here that touches all three vertices of the triangle, A, B, and C. Okay, the center of this circle is the circumcenter of the triangle. All right, so since the center of this circle is the circumcenter of the triangle, this is said to be circumscribed about the triangle. Okay, you can write this down as your fifth vocab word. All right, your circumscribed circle, okay, it contains the three vertices of the triangle. So the triangle is inside the circle, and the center of the circle and the circumcenter of the triangle are the same point. Okay? Now, there's three different ways that you can get the circumcenter of a triangle. If you have an acute triangle, your circumcenter will always, 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 always be inside the triangle. If you have a right triangle, it will be on the triangle, and obtuse triangles, it'll be outside the triangle. Okay, so it can be in, on, or outside of the triangle. All right, but each of these will still hold true about the circumscribed about triangle. I mean circle. If you were to draw a circle around here, the centers would still share. Same thing with the obtuse, same thing with the acute. Okay, so your point of concurrency of your perpendicular bisectors can either be in, on, or outside, and it is called the circumcenter. Okay? Make sure you remember this. Now, you also have the concurrency of the angle bisectors. Okay? The point where the angle bisectors meet, which in this diagram is P, and you can tell it is the angle bisectors because both of these angles are congruent, both of these, and both of these. Okay, this is called the end center of the triangle. Okay, it's called the end center where the angle bisectors meet. Okay, now what's special about this is the distance of point P perpendicular to each side is the same, right? So XP is congruent to PZ, which is congruent to PY, right? So the incenter of the triangle is equidistance from the sides of the triangle, where the circumcenter of the triangle is equidistance from the vertices of the triangle. I'm just going to have to write it down and commit this to memory, guys. Okay? Now, just like we had a circumscribed triangle, since we have the incenter, we now have an inscribed circle, right? The inscribed circle, it shares the incenter, the center of the circle shares the incenter of the triangle, and it also touches the triangle at the same points. Okay, you notice that px, py, and pz, they're all the same length, and where the perpendicular line hits each side of the triangle, the circle will also hit those 3 points. Okay, so now you know about the circumcenter and the incenter of a triangle. The circumcenter is the perpendicular bisectors. The incenter is the angle bisectors. Okay, you're going to have to remember that. The circumcenter deals with the perpendicular bisectors, and the incenter is the angle bisectors. It's the point of concurrency of the angle bisectors. Okay, and remember, these will be the same length here, and then if we go back from the circumcenter to the vertices of each angle are the same length. Okay, you need to remember that difference. The circumcenter, it goes to the vertices, and they're the same length. The incenter, it goes perpendicular to each side, and those are the same length. Okay, so I'm trying to do a quicker video here. So here's your ticket in the door. It says, what are the coordinates of the circumcenter of the triangle? Remember, the circumcenter is the perpendicular, bisectors. Okay, and remember, perpendicular lines, their slopes, can't forget this, their slopes are opposite reciprocals. Okay, and then here in the figure below, TV is 3x minus 12, TU is 5x minus 24. What is the value of x? Well, if you notice, BT and AT are the angle bisectors. Okay, remember, angle bisectors, the distance to each side is the same length. And then for the circumcenter, remember, it's the point of concurrency of the perpendicular bisectors. I will give you a little hint on the perpendicular bisectors. You really only need to find where 2 of them intersect, because of course they all 3 intersect at one point. So if you find the point where 2 of them intersect, the third one's going to have to go through that point. So all you really have to do is find 2 of them, and it'll give you the point for the circumcenter. And here, just remember, these will be the same length, so you should be able to find x. Okay, so good luck. Make sure you have this tomorrow ready to go in class.